As you can see, we have an array, and what we can do is we can make this array behave differently. We can make it behave like a stack or a queue or a linked list or a tree or a hash map. This obviously would be possible through programming. So we are going to program differently to make the to make this array behave like a queue, or program it differently to make it behave like a stack. So it is all possible through programming. To begin with, we are going to try and model, or we are going to try and make this array behave like a queue. So that's the first one that we are going to do. We are going to try and make this array behave like a queue. But before we start programming, let's take a look at a simple animation of how a queue works in real life. Let's just imagine that our queue has one person standing in the line. So because there's only one person in the queue, so he is the head of the queue and he's also the tail of the queue. And anytime a new person joins the queue, he or she joins behind the first person or whosoever is standing in the queue. So the new person is always going to join at the end of the queue, and we can see that the tail of the queue is now the last person in the queue. And now a third person has joined the queue, and since she is the last person in the queue, she becomes the tail of the queue. So what happens if a person is to leave the queue? Just like in real world, the person standing at the front of the queue is the person to leave the queue first. So the person at the front of the queue is going to leave the queue, and now we have a new person at the head of the queue. So we can see that every new person joins at the end of the queue, and the person to leave the queue is always the person at the front of the queue. So the head and the tail of the queue keep changing. Alright, so let's now go back to how we are going to use the array to behave like a queue. One of the first things that we want to decide is what kind of data do we want to store inside an array. Do we want to store integers? Do we want to store string values? What do we want to store in our array? For our example, we are going to define a record first. Remember, a record is a user defined data type, so we can choose what fields we can have within the record. So what we're going to start with is a record. So we're going to declare an array that is going to hold records inside of it. So let's take a look at how we are going to start with this. Okay, and here's a picture diagram. Here's a diagram of what we want a record to look like. We want a record to have two fields. One of the fields, or one of the data items inside the record, we want it to be a string value, and the other one we want it to be an integer value. So our record is going to have two fields, and the name of the first field, or the identifier of the first field, is name, and the identifier of the second field is ptr. Okay, so these are the two data items within our record, and this is how you declare a record in pseudocode. You use the keywords type and ntype. These keywords are used to define a record. Okay, and we can see that we've declared name as a string and we've declared ptr as an integer. So these are the two fields inside of our record, and we've also chosen a name for our record. We've decided that we are going to call our record as a node. So node is the name of our record. So once again, a record is a user defined data type. So we've declared our own data type, and we've decided to call our data type as node, and within a node we've decided to keep two fields. And what we've done now is that we've said that our array, we are going to call it queue, right? And we've declared our array here. What we are saying here is that the identifier of our array is queue. So this here is the identifier of our array, and we are saying that our queue has a lower bound. This, remember, this is the lower bound of the array, right? A lower bound of 1, which we can see here. So this is our lower boundary, and an upper bound of 4, right? And you can see here that this is the upper boundary of our array. So we have declared our array as Q with the lower and the upper boundary. And what kind of data is the array going to hold? The array is going to hold node. So that's the data type of our array, okay? And we've already defined a node, and this is what a node looks like, right? So each element of our array is going to have a node inside of it. As of now, we can see that all of these nodes do not have anything inside of them. They don't have any data inside of them, right? So all of these nodes, we can say all the nodes inside the array as of now are free nodes. They are free nodes. What we want to do now is that we want to link up these nodes. So what we want to do is we want to link this node to this one, we want to link this node to this one, and then we want to link this node to this one. So effectively we want to create a chain. We want to do something like this, we want to connect these together. So this is what we want, and this can be achieved by using the PTR variable, right? The PTR data item, this is the PTR data item, right? This part here is where we are going to store the PTR value for each node, right? So we can achieve linking all of the nodes together by using this PTR field of our node. So basically the PTR variable of this node, for example, the node lying in the first element, to connect this to the next node which is lying here, right, in the second element, the PTR variable of this node should hold the address of where the next node is lying in the array. So the PTR variable is going to hold the address of where the next node is lying in our array. So the next node is lying in element number 2. That's why we are saying this PTR variable here, the value 2 here is suggesting that the next available free node is lying in element number 2 of our array. And for this node, the PTR variable should hold 3 because the next free node is lying in element number 3 of our array, right? And for this node, the value should be 4 because this PTR value 4 is telling us that the next free node is lying in location number 4 or element number 4 of our array, right? And we can see that this final node number 4, right, node lying in element number 4 is not connected to any other node, so it does not have a next node. That is why we are going to use a rogue value here. What kind of a value are we going to use? We are going to use a rogue value, and a rogue value means any value that can indicate that we've reached the end of our nodes, right? We've reached the end, right? And we can use a value like null, for example. Okay, so null is used to indicate that this node does not have any node connected to it, so there is no next node after this. And we should be careful when we are selecting a rogue value, because a rogue value should be such that it cannot be used as an index value for our array. For example, null cannot be an index value for our array, or we can also use the value -1 as a rogue value, because any array which we have cannot have an element that has an index value of -1. So the rogue value, we have to be careful when we are selecting the rogue value. It should not be a valid index value. And null, we know, there is no element number null in our array. So null is a valid rogue value. -1, -2, -3, any negative value can be a valid rogue value, because we do not have a negative index value in our array. So I hope you understand this concept. Alright, and what we've done here is that we've set up a for loop, right? And this for loop is going to run 3 times for index is equal to 1, 2, 3. So this is going to run 3 times, and each time this loop runs, what we are doing is that we are setting up the PTR value equals to this expression, right? So when index is equal to 1, in our array Q, at element number 1, the pointer value is going to be set to index plus 1. So index plus 1 would be 1 plus 1, and that is equal to 2, and that is exactly what we've done here. When this loop runs the second time, index equals 2. So when this statement gets executed, at memory location Q, the element number 2, its PTR value needs to be set to index plus 1, and index plus 1 is going to be 2 plus 1, right? So this is going to be equal to 3, and that is exactly what we've done here. And when this loop runs the third time and the final time, index value is 3. So what we are saying here now is that at memory location Q, in the element number 3, because index is equal to 3, right, the PTR value is going to be set to index plus 1, basically 3 plus 1, which is equal to 4, and that is exactly what we've done here. So we have set up the pointer value of each of our first 3 nodes, and what we are doing here effectively is that this node, its pointer value is telling us where the next node is lying in the array, and this node, its pointer value is telling us where the next node is lying in the array, and this node, its PTR value 4 is telling us where the next node is lying in the array. So now that we've done this, this is the only one that's left, right? This is the odd one out, because here we are not following the sequence of 2, 3, 4 and 5. This is the odd one out. This is where we have to use a rogue value to indicate that we've reached the end of our chain, and therefore this does not have a next node. So we are going to use the value null to indicate for the 4th node. We want to use the value null to indicate that we've reached the end of our chain, and that this is the last node and it is not connected to any other node. So for the 4th node, we have explicitly written this statement separately, which says that in a memory location Q, go to the 4th element and set the pointer value equals to null. Alright, so what we've done is we've successfully been able to create this chain, right? Something like this. We've linked up all the nodes, but what we want to do now is that we want also to be able to identify or tell where the first node of this this free list is lying, right? And remember, this is the first node, right? So we want to have a variable, let's call it the free list pointer, and that variable is going to tell us that where inside our array is the first node of this free list lying. And as we can see from this particular diagram, that this is where the first node of our free list is lying. So our free list pointer should basically tell us that at the start it should tell us that the free list is that the first node in our free list is lying in element number 1, right? And then that first node is connected to the second node, and then the second node is connected to the third node, and the third is connected to the fourth node, and so on and so forth. But the first node is lying in element number 1, right? So the free list pointer should be holding this address value so that we know where the first node of our free list is lying initially when we have done the setup, right? And it's lying at location number at element number 1 inside our array. And so we've declared a free list pointer, a variable called free list pointer, right? And its data type is integer, and its value has been set to 1, right? To 1, right? And so basically this is telling us where the first node of our free list is lying inside of our array. And finally, we are going to need 2 more pointers to complete our initial setup, and those 2 pointers would basically mark, or they would be used to point towards the start of our line and the end of our line. Remember, this is a free list right now. So what we have here, this is a free list, right? And no one is standing in the line so far. All the nodes are free, but eventually what's going to happen is that people are going to come and stand in the line, right? They're going to join the queue, and then we are going to need to point, we're going to need to have 2 pointers, one to point at the start of the queue or the start of our line, and the other one to point to the tail of the line or the end of the line, right? So we're going to need 2 pointers for that. And initially, because there's no one standing in the line, both the pointer values should be set to null, because we don't have anybody standing in our line. So there is no person standing in our queue. Therefore, both the pointers should be null initially. There you go. So what we've done is we've done 2 more declarations. A variable called head, which we are going to use as a pointer, and a variable called tail, which we are going to use as a pointer, right? And this completes our initial setup. We have successfully created the free list. We have a free list pointer that tells us where the starting node of our free list is lying inside our array, and we have also set up the head and tail pointers, which we are going to later use to indicate where the head and tail of the queue are lying inside our array.